In this video, I'd like to do a few more examples with sign numbers and just remind you that these rules apply to everything. So also to fractions, decimals, order of operations, evaluating, etc. So once you know the sign number rules for integers or kind of more easier problems, you can apply it to all the different problems as well, and the rules will still hold. So as you apply it to more challenging examples, though, you do have to keep more just in mind, right? So now you have your sign number rules, but you also have to keep your fraction rules in mind, or how to work with decimals, or how to work with order of operations, etc. So it can be a lot to keep straight. So let's do a few more examples. Now, the first example here, we're taking -7/10 and we're adding it to -1/10. Remember, for adding and subtracting fractions, you do need common denominators, which luckily I already have, so that's good to go. So now think about your sign rules. I'm adding, and they are the same sign. They're both negative. So what's going to happen is I'm going to add them together. So I have 7 and 1 is 8/10, and I'm going to keep the sign. So remember, for adding, if they're the same signs, we add them and we keep the sign. Now, this is a fraction problem, though, so I do also have to reduce and simplify this. I can divide these both by 2, which would leave me with -4 in the top and +5 on the bottom. Now with negatives, by the way, in fractions, you can write it like this. You can also write it out front if you want. That's also common. Technically, you could also write it with the negative on the bottom, although we don't do that as often. We tend to put the negative either in the top or out front, but all three are correct, and they all mean the same thing. In our second example here, we have decimals. I have one positive number that I'm adding with one negative number. So because they're different signs and they're being added, we actually subtract those numbers. So maybe off to the side, I could do something like 11.4 minus 4.7. If you're doing this by hand, remember you're lining up your decimals. I have 14 minus 7 is 7. Decimal point comes straight down, and 10 minus 4 is 6. And then just make sure you think about your final sign. There are definitely more positives than negatives, right? 11 is a larger absolute value than 4 is, so this is going to stay positive. In my next example here, I do have fractions again. I am also adding, but I see I have different denominators, so I have to fix that. So before I even think about my sign rules, I'm going to fix my fractions. And the one that would work for both of these would be 40. I would have to multiply the first fraction by 5, and that would give me -15, and the second fraction by 8, which would give me 16. Now think about your sign rules. I'm adding, but I have different signs, so I'm actually going to subtract these. 16 minus 15 is 1, and then you want to think about the sign. 16 is more than 15 is, so there's more positives here, which means my answer is going to stay positive. In the next example, I have decimals. I see I have multiple steps, and they're all adding and subtracting. So I'm just going to work left to right. When I have adding and subtracting combined, we're just going to work one at a time. So on the left here, I'm going to notice first that these two negatives are going to cancel, right? They're going to end up being positive. So when you have that negative touching a negative like that, they'll cancel out. So now think about your decimals. I'm looking at 1.6 and 10.3, and I'm adding those together. So I would get 11.9. And then I'm going to bring in the -2.5. Now I have a positive and I have a negative. So I'm actually going to subtract those values. And when I do that, let's see, I get 9.4. 11 is bigger than 2, so I definitely have more positives than I have negatives. So this answer will stay positive. In my next example, I have decimals again. I see a subtraction problem, but I notice that these two negatives or subtraction signs, are right next to each other. So they cancel out. You end up just getting 8 plus 4 plus 2.5. So I'm just going to do this off to the side. And I get 10.9. Here I have fractions. I do see I'm subtracting, and luckily I already have common denominators, which is great. So I can jump right in. Again, this right here is going to just become a big plus sign. That's it. So this is -5/8 plus 1/8. But I have different signs. So I'm actually going to subtract. 5 minus 1 is 4. So this becomes 4/8. And think of it, it was -5 and +1. There's definitely more negatives there, right? 5 is a larger absolute value. So this would be -4/8. Now I am going to simplify this. I can divide these both by 4, and I end up with -1/2 as my final answer. For the last one, we do have an example with division here. So obviously we have multiplication division rules as well. So I can do this and just think about it. Again, think about both pieces here. So one is that I have a sign. I have a positive being divided by a negative. So I know for multiplying and dividing that my negatives cancel in twos. So because I have only one, it's going to stay negative. So now my answer will be negative. But let's think about the fraction steps. If I'm dividing, the first fraction stays the same. I change to multiplication, and then I flip the second fraction. Now, it doesn't really matter where I put that negative. I actually don't need it anymore because I know my answers are going to be negative. I've done that already. Here I can multiply straight across now, -8/15. And I would see if there's anything else I can do to simplify there, and I can't. So again, as you start to learn and build on these rules, you have to really keep them straight, and you really have to drill them and know them so that you can jump back and forth between the sign rules or your fraction rules or your decimal rules or whatever it is you're working with. I also want to do a few examples, a little bit more with just order of operations here. Again, just a little bit extra practice with some of these. So here I have some larger fraction problems. Remember when you have a division problem like this, even though it's division, we actually think of the numerator and denominator sort of separately first. So you clean up the numerator, clean up the denominator, and then look at the overall fraction at the end. Here on the top, I see multiplication. So I'm going to do that first. The two negatives will cancel there. So it's two negatives multiplied to a positive. So I have 36 plus 3 up top, which is 39. In the bottom, I see I have a -7 minus 2 or -7 minus -2. So that's going to turn into a big plus sign. So I have a -7 plus 2, which is -5. Now, there's really not much I can do with this 39 over -5 here. So I can either leave it like this. I can change it to a mixed number. Either way is fine. If I want to do a mixed number, 5 goes into 39 7 times with 4 left over, and then I would just stick the negative out front. When you are changing between mixed number and improper fraction, ignore the negative throughout the change and then just tack it on at the end. For the next one here, I do see, again, same process. I'm going to do the top first and then the bottom, and then I'll do the fraction at the end. So here I see a square. So it's -3 times -3. That will become a +9. So be really careful with your exponents. Then I would do 2 times 9 is 18. And 18 minus 20 is -2. In the bottom, I have -5 plus 4 is just -1. So at the very end, 2 divided by -1 is +2. Those 2's cancel. Those 2 negative cancel. And then 2 divided by 1 is 2. I can also apply this to variables when I plug things in and evaluate. So for instance, here, I'm going to use my expressions and let x be -2 and y be -4. So I would do 4 times -2 minus -4. Notice that I do love to use parentheses when I evaluate my expressions. It just makes it easier to see what my operations are. Here I can clearly see I am multiplying now. 4 times -2 is -8. And then also, it's reminding me that I have a subtraction sign, but my number was also negative. So this is actually just a plus sign here, right? So -8 plus 4 is going to be -4. Here as well, I'm going to take my x and replace it with -2. And my y and replace it with -4. Now notice here that just the x is being squared, not the 3. So I'm going to go ahead and just square the -2. So that's -2 times -2, which is +4. So in the top, I have 3 times 4 is 12. And the bottom, 2 times -4 is -8. I can divide these both by 4, and I have 3/2 with a negative. And again, it doesn't really matter where you put that negative. You can put it on the top, in the bottom, or out front. You could also change this to a mixed number if you wanted to as well, but I'm going to leave it as -3/2. And in my last example, just bringing a little bit of review here with absolute values as well. Don't forget the absolute value symbol are those vertical bars, and it is the distance from 0. So it basically makes everything positive pretty much. So the absolute value of -2 is going to be 2. Absolute values do count as parentheses, by the way, so they should get done typically earlier in the example. And I also see another set of parentheses here. -3 plus 4 is +1. Next, in order of operations, I see my exponent. 6 squared is 6 times 6, so that is 36. And then now I have adding and subtracting left, and I am going to work left to right here. So 2 plus 36 is 38, and 38 minus 1 is 37. So in this video, sort of just a mismatched group of problems here that are, all using sign rules, but just kind of taking a little bit further. So reminding us that we can use those sign rules with fractions and decimals. We can use those sign rules with order of operations, with absolute value symbols, with plugging into expressions, and so on. So all of those sign rules really are super important. They're going to be throughout the entire class, but beyond that, in everything in algebra, we see sign numbers. So they're really important that you learn those rules really, really well and get comfortable working with them in lots of different scenarios.